Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Welcome coders! Part 11. We're going to look at what happens when the player dies. Now let's just first have a look at what it looks like. We got that blue sprite coming up, bouncing up and down, and I got the white one here. And when I touch, I get a message, press fire to restart. And I press fire and I come back. So that's the thing. Okay, so the last time I was looking at this sprite and I was wondering why it came up. And it passes through this character, so it's not blocked. And on the way down, it is blocked. So I was wondering what was causing that. And it's actually quite simple. There's two functions. They're called is character blocking or is character blocking fall. And I'll show them here. And so going up, your check. The only characters that are blocking are the ones that are over 128, and going down, you're checking characters that are over 96. So there's a difference there. So this is why we can go up through a character and not down. So we're doing a different check there. So that's clear enough. But what happens for the rest? Let's have a look at what's new. We go to the data first again. There is an X-bit table here that is not being used. I saw that when I compiled and it said, or when I assembled and it said unused label, X-bit table. And this is it. I can only guess at its meaning, but it's 0 and it's 1 with the 7th bit, or the bit number 7 set. But it's unused, so we don't know yet what it's going to be for. There's a text, press fire. There is an asterisk at the end, which probably means that is the end of the message. And there are two booleans here, 2 bytes, button pressed and button released, and they are both initialized at 0. Which is odd because on the outset, of course, well, it's not odd, it's a choice, but I would say, well, button released on the start of the game is 1 because you're not pressing the button. But before you've actually detected it, probably better to set it to 0. But the power of initialization, people, don't underestimate that. Let's go to the main loop. There it is. There's a new function called dead control, which is called at the start. After the wait frame, we first check for death, which is a very gaming, it's really a gaming thing. So yeah, let's have a look. Dead control, it's right here. It just checks whether checks the sprite active table. This is a table. Checking it like this with no index means you check the first element, which is the player element. So if it's equal to 0, so that means the sprite has been removed, the player is dead. Which means as much, that anywhere inside the game where the player object is removed, at the start of the game loop, you're going to detect that, and the player is dead. And what do you do then? We'll see later at the collision detection that there's a couple of changes as well that actually removes the player from the screen and puts the message on the screen because we want the player to press a button. Now, technically, I'd say dead control. I would put the message displaying inside this bit because now you have part of the thing that happens when you die in the collision and part is in this. So it's split across two parts of your code, which is generally not a very good idea because debugging code normally is hard, but debugging assembly is even harder. So you have to make it as easy as you can for yourself. Dead control. So the player is either dead or not. When he's not dead, then we just jump out. When he is dead, now this is my code. I changed this code because it was working, but I suspected that it wasn't working as intended. Now, I don't know the exact intention, but as the code works now, when you press the button and you release, that is when you start over. The way it worked, and I'll show what that code looks like, is that when you press the button, it would restart, and then you release the button in-game. So that was kind of weird, and I think, because of these, the presence of these booleans, I thought, well, let's, I assumed that he would want to test for release, press and release. So we'll look at the original code. It's in a different editor. It's in Sublime, but this is what it looked like. I don't know if I can zoom in, by the way. Let's see if I can do that. I don't know. Enter full screen layout. View edit. No. Find maybe font. Oh, wait a minute. Maybe it's as easy as... Okay, there we go. Make it a little bit bigger. There we go. This is what happened. The player is dead. This code just checks a hardware register for the button being pressed. If it's not equal to 0, then there's no button pressed. And what you do is you set the button released to 1 and you jump out. Now, when you press the button, it says, hey, button is pressed. It checks for, hey, is the button released? If it's not 0, then restart. Well, we've just set it to 1, so it just restarts. And if it is 0, but it can't be. You can never reach this code if the button is not pressed. So if it's actually released, you can never come here. So this works on button down, but not button up. So, but it works. It still works. Also, I'm gonna move it out the way again. Also in the collision code, let's jump to the part where that happens. See if I can find it quickly. Oh, is enemy colliding with player? There we go. Is enemy colliding with player? We'll just scroll down that and. Oh, wait a minute. The player collided with enemy. That's it. Right. This is where the text is printed. So player collided with enemy. Just assume that this the whole mechanism worked as we left it, which it does. We get the address of the press fire text, and we set a couple of parameters to the positions, and then we just jump to display text. We'll look at this function in a minute. Because this is not just a display text. It also takes into account like new lines and all that. So it's really smart. So it displays the text, and I've changed this because it basically said button released and button pressed were both set to 0. And then it jumps to remove player object, and it jumps out, and in the next iteration of the game loop, it'll then detect that the player's died. But I moved this around, and I set button released to 1 because we're not pressing the button at this stage, and button pressed to yes. Technically I could be pressing the button at this point, but it's still a small window for error, I suppose. But it seems to work now. So now what we do is when the button is not pressed, we go to this place and then we check for is the button pressed. Now we know that the button isn't pressed, but I want to check if the button had been pressed before. Now, button is not pressed means check if it was pressed. If it's not, then we set button to released and button pressed to 0. And this is where you see it happening, because let's assume that we are pressing the button is pressed, then we set button pressed to 1, button released to 0, and then we jump out. And in the next pass, we'll say button is pressed, we get here, and then we'll detect button is pressed, yes, because we set it to 0 here. And this is where we, as soon as we release the button and we detect that we had pressed the button before, that's when we say restart. So this is sort of a tiny finite state machine, and it just has 2 states. But you want to check for a released button after it had been pressed. So that this is actually the way I think it was intended. A restart says just put the player at the original position. These are character positions. Take the type player. Oh, okay. Yeah. Set the index to 0. Get the player type. Put that in the sprite active table, because that's what we expect there. Then calculate the position again. Enable the Vic sprite. This sprite enabling, this is kind of dirty having it here, because this code is now double. It's probably somewhere else already. So we initialize enemy values. That's what it says here. But basically we're taking the sprite player and setting the sprite pointer base. I think this hasn't changed in the meantime. It may have, but because basically what we're doing when we find an empty sprite slot, we might end up choosing the player spot. So who knows? The player by default looks to the right, so we set its sprite direction and then we clear out, and then we're done. So let's have we look before we go to the text display. I wanted to. What did I just say? Oh yeah, find empty slot. I see. Find empty slot starts at the beginning. So when the player dies, we may, and before he presses the button, we may actually be in a situation where the player spot is taken by an enemy or by an object, actually. So that it's good to realize what might happen in that time. But let's go back to here. Oh no. Player collided with enemy. This is the display text function. I'm having a little bit of trouble, by the way, in navigating, even though this is a great summary. The problem is that this is based on the zone information, and a zone starts wherever you put a zone. I'm just scrolling here. There's a dead control, but everything that comes below here is part of that zone, and that makes it all the functions that are that may not be part of it will be located there. So I'm having a little bit. If there was like an end zone thing, that would definitely help me. Anyway, display texts. Go to declaration. So we have a text in memory. We expect the y and the x parameters there. So we load the y parameter. We get to we get the low part of the address of the first character of that line. We do the same for the high part, and we calculate. We've seen this before. We get to the color RAM in the same way. We put the high part in 0 page pointer 3 plus 1. Then we get the address of where the character is supposed to go. We add our x parameter because we don't want to print at the start of the line, but at the x parameter. And we store that back into the 0 page pointer. We do the same for the high end. This adding 0 is just so that we can add the carry if the previous calculation led to a carry. That means we've crossed a page boundary and we carry that over to the high part. We do the same here again for the color RAM. There's no difference. And then we just loop through the text. So we get the character that we set y to 0. We get the character. We compare that character to 2a, which is the asterisk. Then, if we hit the asterisk, then we're done. We also compare for this character, which is a hyphen. Let me get the Petsky character sheet. This is 245 is 2D, which is this character. And the other one, the asterisk, is 2A. Where are we? Right there. This is that's that one. So, if we run into a hyphen, we do a line break, and otherwise we just store the character. We load the color 1, and we store the color, and we go to the next character. Now, what happens in a line break? We transfer the Y, which is our index into the text, to the accumulator. So that's just like a 1, 2, 3, 4, 5, as long as the text can go. We clear the carry. We add the low part of the address to the carry, to the accumulator, and we store that there. Then we load 0, and we set that to 0, and we add the high part this time, still keeping the carry for the last time we did an addition for the page boundary. So we're basically setting the 0 page pointer 1 correctly, and the 0 page pointer 1 is pointing to the text. So why would we store this back to its own place? It's already there. So we're changing the 0 page pointer to point to the start of the string after the new line. I don't really see the point in that, but okay. I do understand what happens here. As soon as you hit a line break, you're going to run into trouble with the index, really. So because the index y is used in the text that you want to print, as well as the index to the character and color memory where you want to put the characters on screen. So you want to keep the index running, but when you're going to hit a new line, the index for the y is going to go back. So we have to devise, and the index in the text is going to go on. So that's a problem. And the way that we solve it here is we just set the text pointer to the first character. We have to increase Y because Y is at the actual line break character. We increase it to the next character, which is the first character of the second line. Then we calculate the address of the beginning of the new line. We store that in 0 page pointer 1. We increase the line by 2, and then we jump to display text, which just does a display text as if it was a single line. But this time we've just changed the 0 pointer to the start of the new line. And, to be fair, display text does all this work again, so it calculates the address again, this time with a new value for parameter 2, so it's sort of justified. And then we go on. So that's the way that we interpret a line break. And then parameter Y was our Y position on the screen, so we increase that by 1, basically meaning that if we do a new line, we get an extra line, an extra empty line. I can demonstrate how that works. If I did this, and is enemy colliding with player, I'd have to. Oh, yeah, there we go again. Player collide with enemy, make the same mistake. I have to pull this up a little bit. If I did it like this and go like that, and then go ahead and die, I get press fire to restart, and I get an extra empty line there. So that's how that works, and that concludes this episode. So. Mildly interesting, but I thought it was interesting because I removed some bugs, and that made me feel good. So, thanks for watching, and I will see you in the next episode. Bye-bye.